Good morning, everybody. Let's talk about our math lesson for today. For the class activity, we are looking at Unit 5, Lesson 8. This will go along with Unit 9, Lesson 8 for your homework and remembering. All right, so in this lesson, we are talking about square numbers. Now, what in the world are square numbers? Well, if you're looking at your class activity page, you'll see that we have many different kinds of squares here. Well, let's learn all about it. Each one of these little squares, remember, is called a square unit because it is square. All sides are the same length, same measurements, and we're just calling it a unit because this isn't really a centimeter or an inch or a foot or anything like that. So we just call it a unit. In this one here, on number 1, it shows us 1 times 1 equals 1. That's because there's 1 across, 1 down. If we write our multiplication equation for this, it kind of looks like an array. It'll be 1 times 1 equals 1. So now, let's jump over to number 2. What does this look like? I already have these top 4 numbered for you, but we have 2 across the top and 2 down. So what kind of an equation are we going to write to solve for this figure? If you said 2 times 2 equals 4, you're right. Now, it's kind of like finding the area, okay? Because we have 2 across the top, 2 going down. When we write that equation, we have 4 units. 1, 2, 3, 4. Perfect. We're writing an equation to show the area of each large square. So we did number 2. Let's jump to number 3. I have it numbered across here. 3 across the top, 3 going down. What's our equation going to be? 3 times 3. And what is 3 times 3? 3, 6, 9. There we go. Okay? And so on. 4 times 4 equals 4, 8, 12, 16. Okay, what do you notice about these first 4? Well, they're all squares. Maybe they're getting a little bit bigger as we go. And the sides are exactly the same because they're squares. And that's kind of how we talk about square numbers. That's just a number times itself. 1 times 1, 2 times 2, 3 times 3, 4 times 4. They make a perfect square because there's the same amount of units going across the top as there is down. All right, so take a moment, pause this video, and finish this page. And when you're done, press play again and go. All right, now that you're done, let's do a quick recap of this page. I'm not going to write anything down, but I'm going to go through these real quick. There's 5 across the top, 5 going down. 5 times 5 is 25. And 1, 2, 3, 4, 5, 6. They're just adding 1 each time. 6 times 6 is 36. 7 times 7 equals 49. 8 times 8 equals 64. 9 times 9 equals 81. Last one, 10 times 10 equals 100. Square numbers are very helpful to know because you can either count up or down, or like if we have 9 times 9, and we know 9 times 9 is 81, and we need to know what 9 times 8 is. We just subtract 9. Square numbers are just really helpful to know. Let's turn our page. Let's talk about some patterns that go along with square numbers. Make sure this is in the camera here. All right. So they want us to list the products, the answers in each exercise 1 through 10 in order. Discuss the patterns you see with your class. So let's over here just do that really quick. What's 1 times 1? 1. What's 1 times, or 2 times 2? 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. Okay? We're going to talk about this table a little bit and then go back up to here. The numbers you listed in exercise 11 are called square numbers, just like we talked about on the front side, because they are the areas of squares with whole number lengths and sides. A square number is a product, so the answer, of a whole number and itself, so a number times itself. So if n is a whole number, that means that n times n is a square number. Remember, n is just a variable. Like when we have our function tables, that just stands for any number. But that means it's going to be the same number times each other. So if we put 4 in for n, that would be 4 times 4. If we put 8 in for n, that would be 8 times 8. Square number. Number times itself. Okay? Now let's look at this table down here at the bottom real quick. In the table, circle the products, the answers, that are square numbers. Discuss the patterns you see with your class. So we have 1 times 1. Let's circle it. 2 times 2. Circle it. 3 times 3. Remember, it's where our fingers meet. 9. 4 times 4. 16. And so on. Keep going. 25. If we look up here, 36. 49. 64. 81. 100. What do you notice about the numbers we just circled? If you said they make a diagonal line going down and to the right, that's correct. What else do we notice about this? Maybe our diagonal is forming a line of symmetry? Yeah, I think so. I think if we fold our table in half, we would have a line of symmetry. What else do we notice about our square numbers? Well, let's look back up here. Let's do the difference here. The difference between 4 and 1. 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 9. What are we going up by? We're increasing by 2 because 36, 25 is 11. Then we have 13. Then we have 15. Then we have 16. All right. Very cool. Okay? So, let's do something else real quick here. If I have, well, first of all, let's put an X on 21 here. The product of 7 and 3. Okay? Whoops. I'm just noticing this. This is 17. And this is 19. Sorry. Okay, back down here. Refocus, Miss Ronigan. If we put an X on 21 over here, if we look directly across this table to 21, let's put an X there. Remember how we said lines of symmetry? If we fold them in half, all points should meet up. This 21 will meet up with this 21. That's the product. So I'm just going to put 21 over here twice. What are the factors to get our first 21 up here? Factors are which numbers times which numbers? 7 times 3. Okay, how about down here, this 21? 3 times 7. This just goes to show us what we've been talking about with our fact families, that they are interchangeable, okay? The commutative property. If you switch them around, they still equal the same thing. They're just in different order. So this is 7 groups of 3, 3 groups of 7. They look different when we draw them out. But it just kind of shows us the different patterns on the multiplication table. It would be the same thing if we wanted, let's pick 20. Okay, and then across the table, line of symmetry, 20. We have 5 times 4, and we have 4 times 5. Okay? Very similar. So you have this to do, which you should have done, and we talked about all the patterns in the multiplication table. So that's your math for today. Tomorrow you have the homework and remembering. Let me know if you have any questions.